Hi everyone, today we want to talk about how to do t-test statistics using JMP. T-test statistics again compares the mean of two different groups that are here. We want to talk about the independent samples. So for example, if you wanted to say and compare the completion time month between strategy 1 and B, like we use two different strategies for completing a project, a task, and we want to see if a strategy A and B, like how they differ. So we could have put a couple of potential hypotheses. For example, we could just compare a two-tailed test, which just look at, we wanted to see if these means are different. We don't know if any one is greater than the other one. We just want to see if different. This is preferable if you don't have any other previous tests or literature supporting any direction. So you go with the two-tail if there are different. And our null hypothesis would be no difference, and our alternative hypothesis would be that if they were different. In other ways, if we had some previous studies and predictions that one group was bigger than the other, then we could test. For example, we could say if the mean completion time month for strategy B was bigger than A, if we wanted to test that as a research hypothesis or alternative, then our null hypothesis would be the complete opposite. And then let's see how we use JMP for doing this test. If we wanted to do that, we open the JMP, open your open your file. To do the t-test, you go to Analyze, Fit Y by X. You pick your dependent variable completion time on Y. Response, and then you put your strategy to X, and then make sure this is categorical and this is continuous, and hit OK. Then you have this graph, and then click on this red triangle, go to t-test, and then it brings you the results. Now let's look what these results mean in the context of our work. First of all, this graph, all of these dots represent the project's completion time. And this line, and it's separated as strategy A and B. This line is the mean completion time for the whole project, regardless of strategy A or B. So kind of like visually you can compare as well. And here, regarding the table we got from our results, first of all, look into this direction. If B comes first and then A next, this is important for interpreting your results. When B comes first, it means that my alternative hypothesis, if it's directional, I'm always talking about is if B greater than A or B less than A. It's not the reverse. So B always comes first. This formula here is telling you that the comparing the mean of a strategy B minus mean of a strategy A, excuse me, and this is the difference between the means. This is difference between standard error, different standard error of the mean differences, and this is our t value. This is our degree of freedom. Again, we talked about how to calculate this. This would be the sample size A plus sample size B minus 2. And here you have like the results. If we went with two-tailed test, this would be our results. If we had tested, let's look at the next slide. If we had tested, if the means are different, then if this number is less than, because we have 95% confidence interval, if this number was less than 0.05, we would reject the null hypothesis. It is less than 0.05, so we reject the null hypothesis and we say, yes, there is enough statistical evidence that there is difference between the mean of a strategy A and B. Here, this is a right tail test. It's testing if B is greater than A, not the opposite. Why? Again, you go back here and you look at your which comes first, and then that determines what this means. B is first. We're here right tail test. We're saying if B is greater than A, if the result was less than 0.05, we reject the null hypothesis. It is, we reject. So we say, yes, there's enough statistical evidence then that the B mean of the strategy B is greater than A. If we had said hypothesized B is less than the A, then we would say, no, there is not enough evidence, and we would fail to reject the null hypothesis because this is not this is bigger than 0.05. And that was for today.